A very good day to Dr. Gan and Dr. Dan. I'm Lee from CDS 522. Let me present my project with title of Text Classification of Medical Transcript. As the increasing amount of storing medical transcript information, the need for timely retrieval of relevant information is growing. One method is to assign topic for each of the medical transcript. In a traditional approach, healthcare workers will spend a lot of time scanning through the transcript with a view on identifying key issues. There are also transcripts with complex cases that lead to information overload, delays, or missing information. Hence, this project will show the NLP approach in classify the medical transcript. The dataset that used in this project is a real medical transcript sourced from MT sample and KGO. It consists of two attributes, namely transcription and medical specialty. The attribute transcription is the predictor, whereas the medical specialty is the target label. Both of the attributes are categorical data type. The dataset has 300 transcription instances, where 108 of them labeled as discharge summary, 94 labeled as neurosurgery, and the rest of 98 labeled as ENT, which is as shown in the bar chart. Now let's talk about solution overview. First, the dataset will be pre-processed by text normalization. Next, 5 types of n-gram feature vectors are extracted from the normalized dataset. Each of the n-gram feature vectors are split randomly into a 0.8 proportion trend and 0.2 proportion test subsets. The 5-fold cross-validation is applied on the training subset in order to find the optimized hyperparameters for the test classifier. After determining the best classifier, then the classifier is trained on the training set. After training the model, the train classifier is then used to predict the unseen data, which is the testing set. Macro F1 score metric will be used for evaluate the performance. The following test normalization steps will be conducted, which are lowercase, remove punctuation and numbers, tokenization, stemming, and stop words removal. After the test cleaning, it has reduced 42.9% less work compared to the word count before cleaning. It helps for the dimensionality reduction, allowing the classifier to be more accurate. Then, 5 different types of n-gram features are extracted, which are unigram, unigram with bigram, bigram, bigram with trigram, and trigram. The features vector are extracted using scikit-learn library called vectorizer. The dimension of the features array are shown in the table, where unigram has the smallest size of column amounting to 7,038, while bigram with trigram features has the largest number of columns, amounting to 114,215 columns. It is important to point out that learning the parameters of a prediction function and testing it on the same data is a mistake. This is because a model that would just repeat the labels of the samples that it has just seen would have a perfect score but would fail to predict anything useful on unseen data. This situation is called overfitting. Hence, the procedure of this classification tasks are shown in this figure below. First, the dataset is split into 80% for training and 20% for testing set. In order to solve overfitting issue, cross-validation is applied on the training data. In this project, 5-fold CV is implemented rather than 10-fold, as considering the data size is not very large, which is 298 transcription instances. The 5-fold CV enables the training set to split into 5 smaller sets as shown in the figure. Then each model is trained using the folds as training data, and the resulting model is validated on the remaining part of the testing data. Grid search is also applied on the 5 CV to search for the optimized hyperparameters. The metric used for the grid search CV in the 5-fold CV is macro F1, which is preferable for multi-class classification tasks. It computes the average of the F1 score of each target class. The main reason of using macro F1 is because this project is a multi-class classification, so that macro F1 can access the average metric for 3 of the class labels. Moreover, macro F1 combines the position and recall of a classifier into a single metric by taking their harmonic mean and average of each target class. Hence, macro F1 is chosen to evaluate the multi-class classification performance fairly. Additionally, there are 3 classifiers to be trained. K nearest neighbors or KNN is a distance-based classifier. Meanwhile, decision tree classifier or DTC is capable to learn the decision rules inferred from the data features and is able to handle multi-output problems, just like in this project. However, it has overfitting issue as it creates over-complex trees that do not generalize the data well. This issue has brought into ensemble learning method. Random forest classifier or RFC able to achieve a reduced variance by combining diverse trees to overcome the overfitting problem. The optimized hyperparameters for each classifier are listed in the figure. After the process of grid search CV, RFC is found to have the best macro F1 score. Hence, this classifier is chosen to make a test prediction. By using the best parameters as suggested by the grid search, it can achieve the best result of 0.93 using unigram feature vector. Meanwhile, unigram with bigram achieved 0.85, bigram achieved 0.83, bigram with trigram achieved 0.84, and trigram achieved 0.57, which is the poorest performance among all. The key finding unigram is the best feature vector in classifying the medical transcript as it can achieve the best result of 0.93 macro F1. As the number of n in the n-gram increases, the performance drops. This may indicate that the adjacent word ordering less important in the classification task. In this context, in fact, considering adjacent word sequence like neighboring words is one of the limitations of n-gram feature representation. Hence, we can deduce that the word ordering for the medical transcript in this context is less important in predicting different medical specialty topics. In this project, text classification for medical transcript has successfully implemented. Several NLP techniques have been used to get this project finished, such as text normalization, feature extraction, and word cloud. The best result of the prediction achieved 0.93 macro F1 on the testing subset using RFC and unigram feature representation. Thank you for listening, and you may contact me anytime if any query.